Hiya! Today I'm going to show you how I built this pendulum clock using a £10 sledgehammer, an Arduino and a few other small components. Why did I do this? Because I can, and because it's a good reason to call this video Hammer Time. All pendulum clocks use a principle discovered by Galileo in the 1500s. He noticed that the time taken for a pendulum of a given length to swing back and forth will always be the same no matter how fast you initially push it. The hammer, that is the pendulum in this clock, swings backwards and forwards once every 2 seconds. The Arduino counts how many times the pendulum swings and works out how many seconds, minutes and hours have passed. The Arduino would have made a far more accurate timekeeper if I disconnected it from the pendulum and made a small change to the code to allow it to use its own internal clock to count seconds. That would have made a better and more accurate clock, but a far less interesting one. A normal mechanical pendulum clock uses a gravity or clockwork driven system to provide a tiny extra push to the pendulum on every swing. That's what keeps the pendulum swinging, because otherwise it would eventually stop due to friction. The trick is to make the push small enough so that the natural frequency of the pendulum is hardly affected. My clock uses an electromagnet to provide that little extra push. The electromagnet is turned on and off by these switches. It turns on when the pendulum swings the furthest away from it, and turns off again when the pendulum is just about to touch the electromagnet. Those same switches send a signal to the Arduino. The Arduino counts these and turns them into a time format that I can read. I'm going to make the Arduino code and the circuit diagram available for anyone who wants to build their own clock. If you do use those plans, I'd be really happy to hear about it. Just leave a comment below, that would be great. First of all, I tried building my own electromagnet using this large old bolt as the core and this very old-fashioned rayon wrapped wire for the winding. This didn't really work very well in the end because it heated up too much when current passed through it, but I thought it deserved a mention here because it looked pretty cool. Looks like something from 1950s space or something. If anyone knows why the magnet might have heated up so much while I was trying to use it, just leave it in the comments below. I'd be interested to know more about how to design an effective electromagnet. I needed to build a frame for the hammer to swing on. I built it out of lengths of scrap wood and triangulated the base for a bit of extra strength. I probably should have built the frame a bit stronger than this in the end because it flexed a little, and that means wasted energy and inaccuracy in the clock. This is the axle that the hammer will swing on. It's running through skateboard bearings to reduce the friction as much as possible, and the axle itself is made from M8 threaded rod. I'm using a piece of angled aluminium to secure the bearings to this piece of wood and keep them as aligned as possible. I screwed the axle to the frame about 1.5 meters above the ground. I used M8 nuts to secure a length of aluminium square section to the axle. I connected the hammer to the end of that square tube. That's because the overall length of the pendulum needs to be a bit longer than the length of the hammer handle in order for the swing to take 2 seconds. So now it's time to assemble the high current side of this circuit. This component here is something I find quite fascinating. It's called a set reset relay. So it's an electromechanical device. There's an electromagnet in here which switches contacts over from one side to the other of a mechanical switch. Well, that description I gave there pretty much describes any relay. The unique thing about this is that it has 2 separate coils, 2 separate inputs. I've connected the negative sides of each coil to negative on my power supply, and I'm now going to touch one set of contacts and then the other with the positive side of the power supply. You may not be able to hear it there, but each time I click an alternate contact, you can hear the contacts of the switch within the relay swap to the opposite side. The thing that makes a set-reset relay special is that it kind of remembers the last state that you sent to it. So it kind of functions as a sort of primitive memory. This could actually work in the same way as a memory circuit containing a single bit on an electromechanical computer. Something which I've actually tried to build with relays in the past. The thing that prohibits that is really the expense of these. These are about £3 each, and they're relatively large. The circuit that would perform the same function as this relay, built out of transistors, could obviously be held on a small integrated circuit. And in fact, of course, something like an Arduino would contain thousands of millions probably of circuits very similar to this. But it's a curiosity, and it's kind of a hangover from the old days of electromechanical telephone exchanges, for instance. Those would have thousands of these in to handle routing of phone calls, etc. This is just a montage of me assembling the high current side of the circuit. I'm not going to bother explaining this in detail because it's better to just follow the circuit diagram. All I'm doing here is creating a connection block to handle all the common connections to 12 volts, and then I'm wiring up these switches with 12 volts going to common on the switches and a wire coming from the normally open contact. The other end of those wires coming from the normally open contacts are going to be soldered onto the set and reset pins of the relay. I'm going to power that circuit using a replacement laptop power supply, which is supplying 12 volts at 5 amps. And I have a circuit that does the same as when I was messing around just holding wires onto the power supply and the relay. I have one switch wired to set and one switch wired to reset, and that's going to be what remembers to keep the electromagnet turned on after the pendulum has swung the whole way in the opposite direction to where the electromagnet is. I screwed the connection block, switches and the DC jack onto the frame and then plugged in the power. I connected my electromagnet so that it could be switched on and off by the relay and screwed it to the frame. However, like I said, my homemade electromagnet got far too hot, so I swapped it for this solenoid. This is a solenoid that I salvaged from an old printer. Inside the printer it would probably have been in charge of moving the paper feed or various things. It's an electromechanical device that just performs a single on-off motion using this electromagnet with the core, fairly similar to the one that I attempted to build myself. It's got an actuator arm built into it, but I don't really need that for the clock. In fact, it will get in the way, so I just removed it. Because it has that flat mounting plate, the solenoid was very easy to just clamp in place, and that was quite useful because it meant that I could adjust the position very precisely. Because the amount of force it generated was quite a bit less than my DIY electromagnet, it meant that I needed to position the solenoid a lot more precisely to make the most of the force that it did generate. At this stage, the clock was able to sustain the motion of the pendulum pretty much forever, but I did need to fine-tune the length of the pendulum a little bit to make sure that the period was at least approximately 2 seconds. That lamp switches on when the solenoid switches on, so it makes it a bit easier to understand what the clock's doing. But I won't bother showing you the whole of the pendulum length tuning. I'll move on to the Arduino. This is the circuit diagram for the entire project. The part which I've already shown being built is at the top right, which all runs on 12 volts. And on the left you can see the Arduino on a breadboard and the LCD display. The Arduino is supplied with 12 volt power to its raw pin, but the rest of that portion of the circuit runs on 5 volts from the Arduino's VCC pin. I hope that circuit diagram is clear enough for people to follow. I do tend to follow the rat's nest method of wiring things, so I apologise for that. Unfortunately, Fritzing didn't have a set-reset relay part, so I've just placed two relays next to each other in the diagram, which stand for the set-reset relay with its two coils and two sets of contacts. I built the circuit containing the Arduino on a breadboard and clamped that onto the frame. Then I screwed the LCD display onto the frame somewhere I could see it. This is the set-reset relay again. The purple wire is connected to VCC on the Arduino, that's 5 volts, and the white wire is connected to pin 6 on the Arduino. That's what allows the Arduino to count the swings of the pendulum. Then I just had to plug it in. Finally, I added two buttons to the clock to allow me to set the hours and minutes. I think trying to set seconds on this is a bit optimistic. This clock is never going to be accurate enough to time things to the second. You see, one of the buttons makes the minutes count up, and the other button makes the hours count up. And that's more or less it. The clock is still running in my workshop a couple of days later. I'm going to keep tuning it to try to make it more accurate. Although it's still fairly accurate already, considering how primitive the construction is. It'd be amazing if someone actually took my plans a bit further and built their own clock, because I think that the housing, the frame of the clock could be built a lot more solidly and a lot more neatly. I think there's a lot of improvements that could be made, so if anyone's interested, if anyone goes ahead and builds their own, please do let me know. I would be very happy. I hope you enjoyed that video. If you did, please hit the like button. Subscribe if you want to see more videos like this, or not like this. I make videos about Arduinos, including the obligatory Arduino watering system. I modified a Chinese laser cutter to run on G-code. I started using that to make laser cut marquetry. I also made a blog about building my own CNC machine from scratch using acrylic sheets and the open build C-beam system. So there's a whole playlist which will kind of show you the process, and all of the designs for that CNC machine are available for you to download, and you can make your own. I used that CNC machine to engrave some veneer to create a replica of the puzzle box from the Hellraiser series of films, which was my entry for the Instructables Halloween contest this year. There's a lot of miscellaneous stuff on my channel, but if you're into maker stuff, you're probably going to find it interesting to subscribe. I'm really happy to have got past the 800 subscriber mark now. I think it's great that even more people are seeing my videos. I'm excited to see what the rest of 2017 is going to be like.